Good morning, ladies and gentlemen. Let's start. Sorry for delay. Some paperwork required more time as expected, but let's continue our course. Today is day 4, and we slowly but surely we are moving into the key results. And today we will be more focused on ontology and some applications. But as usual, let me first start with our agenda. So we need to have 10-15 minutes previous day review. I will give you 5 questions. And then we come back to our laboratory work and we'll discuss what is the technical progress, and we'll try to help if there are some problems. Right. Then we have a lecture, and then after lunch we'll start talking about laboratory work number 2. So we will give you some initial information about how to approach, how to execute these tasks. And so in general, you will be free to select what other laboratory work you will proceed to do. And then there are some changes here that instead of my lecture in afternoon, it will be a lecture from Professor Animesh. And then probably we will give you some time to finalize reports on laboratory number 1. And if there will be some time, then we continue and will continue our meeting from this. So this is our plan for today, and let's start. So first part of our agenda for today is to answer next 5 questions. Take please 15 minutes. Here are the questions. Yeah, can you see these questions on your screen?
Yes.
Okay. Okay, good. So please start and tell me. And again, I'm receiving sometimes very big reports. Just try to put it in a short way. So please, your answers are very welcome.
কোথায় গেছে তোর ভাই? Day-4 outside the
তুমি তাহলে যাও আমি তোমার অ্যাসাইনমেন্ট করে পাঠাচ্ছি কি কি পরীক্ষা চাপে Meaning classes of agents क्या होगा?
टेबल में एजेंट ऑफ ऑर्डर एजेंट ऑफ टास्क पीपीटी में
अच्छा वो वाला या फिर एम्प्लॉई ऑर्गेनाइजेशन में
लिया हमने क्लास ऑफ एजेंट्स इन डिमांड सप्लाई पर है नहीं
अच्छा कौन सा वाला पीडीएफ है? 3 नंबर
हां वो जो लेटेस्ट अपलोडेड मॉडल 2 करके लिखा हुआ देखिए
ओके कहाँ पे वो
व्हाट्सएप में दीजिए लास्ट में जो पीपीटी अपलोड किया था
साइड नंबर 22 देखा दिन सामान लगता है ना वो की बात समझ में वो नहीं होगी
कॉम्पिटिशन में होंगी
ठीक है ना हो जाए प्लीज विजिट दिस स्लाइड नंबर ना देखा तो दिस स्लाइड नंबर साइड पर होगा इवन कीवर्ड स्पेस नंबर स्लाइड तो ऊपर तो नहीं 22 मेन क्लासेस ऑफ एजेंट एक क्वेश्चन देना चाहिए ना
क्लासेस भाई को क्वेश्चन क्या देखो
मेन क्लासेस ऑफ एजेंट
Yes. Finish. Finish.
Dear coach, how are you? How's your progress?
Yes, sir.
Finishing. Almost
Completed, sir.
completed.
Almost completed.
Okay, 2 minutes
Yes.
to send result. Okay. And what about you?
Sir, almost completed.
2 minutes. Ready?
Okay.
Very good. Ready? Okay, so time is over. Yeah, please, done?
Okay.
Okay, very good. So please send what you have. So if you think completed 3 questions, doesn't matter, just send them. Okay? So thanks for your docs. And now let's come back to laboratory number 1, not laboratory work number 1. And I would like to invite here to the stage Naku. It's already our tradition. Please bring your computer with you and tell us what were the programs and what you have achieved.
So, until now, I haven't found the PDF of the reports. I have done the work. I will inform them and I make the PDF and submit it for the black box one. I've done I've worked on the website, but I haven't found the report yet.
Yeah, we understand. You will have time to make a report, but just for us very important that you go through all the tasks. Yeah. Are you ready? Hello? Is this?
Я здесь.
Okay.
from the preliminary start to the
Thank you so
from
much. चलिए तो ठीक है. Sorry.
Back to the again. Back.
Yeah. So please, if possible, just tell colleagues, yeah, what was done briefly.
That's good.
Yeah, yeah, what kinds of tasks, your individual tasks were implemented, and where you had some difficulties, and
Okay.
yeah, how you overcome that all. Valeria will help for
So actually, my problem was in lab work two, which you
what's
discussed.
true. Yes, yes, yeah,
But in lab one, I had no such problem.
yeah,
Just I should have given an overview.
yeah. Just go through
Okay.
and to check that everyone understands, yeah, and then go. Just ask what you class. So,
Excuse me, everyone.
yeah, dear, dear ladies and gentlemen, please raise your hand who completed laboratory work number one. 1, 2, 3, 4. Fantastic result. So then I would like to ask you, do we need that not will go through again just to check that everyone on one way, or it is not needed?
It is not needed.
It is not needed. You will understand the whole thing. Yeah. Okay, then very good. Then let's discuss. Maybe some of you already made some presentation of results. Do you have?
So, has anyone made, excuse me, everyone?
Sir, I have made the presentation which was based on last day's morning pattern. After getting the new UMAS file, how we can able to add the constraint and how that knuckle was invisible first time and after that knuckle was visible. That part I have done.
Okay, very good. So, can you show us the result of your presentation? Yeah.
I will.
Okay.
Just hold on, sir. I'm checking that in this folder I have the presentation.
Yeah, but what is most interesting for me and for Valery, what about individual task number 6, 7, where it was needed to add the new technological processes? Are
Yes, sir.
you successful?
That is what I was trying that couldn't completely time, but I'll do it. But I was going through the lecture materials and I was trying to do it. It will take one more day.
Okay.
Sir, what happened before day 1 we have completed, but we forgot to take the screenshots. Then we need to again do it and from the beginning. So we have completed task 1, but we forgot to take the screenshots. And then at the second time, last day morning, again we have updated with the new UMAS file.
No, don't. So if you go through and if you understand all these things, you don't need to make any additional paper. It's just okay.
So I have done the morning part presentation. That is the constraint part.
Yeah, come here. Yes. Let's show to everyone. Okay.
Okay. So when she should come and show the PPT, I can take my application.
Yes, let her forward.
Print them in another thing.
But then what I'm thinking, so probably my proposal is that
After morning.
yeah, probably we will continue with what we
Yes, it will take some time.
yeah, so we'll take some lunch, so let me go through it.
Sure, sir. I'm just stopping my screen share.
Yeah.
So I have only 7 to 8 slides.
That is
I'm sure they are ready, I'm sure.
Yes, sir. Screen sharing. Enter screen.
Yeah, so please go through your slides and explain the main findings that you made. Please.
Okay. I hope my screen is visible and I am audible to all of you. Okay. So what I have, sorry?
Not visible on the screen.
Oh,
Now it's fine. So what I have done, so first day we had some problem to add the constraint, and the finding was there was some mistakes and the default is false are there in case of your UMAS file, right? So after that, last day we got some updated UMAS file and we have replaced that UMAS file with the existing file, and after that we fixed that bug, and after that we did some things, right? So initially what was the case that after adding 18 orders, then we can get to know that which will be providable and not providable. But lastly, when we have added 10 orders, then we can able to make the constraint and we can add the constraint if we need. So it was the first map which I got after adding the 10 orders, which we used to do from the beginning. The same process we did. First we have started MongoDB. After that we have started IS Manager. Then we have started the backend part, started the planner part. Then we have opened the localhost 8000. Then we have added the orders. Fine. So these are the basic steps. After adding the orders, you will get to know. If you click on the maps part, you will get to know this kind of picture. And I have just taken the screenshot. So this is the part that we can contain that we have added 10 orders. Next, these are the schedules for the 10 orders. So as you can get to know that 3 persons are here, Himesh, Nakul and Srivans, and how the orders are assigned here, that is actually visible, okay? So this is the basic scenario. After adding the 10 orders, you will get to know that how the orders are scheduled to the 3 persons. Next, what was our objective? That after 10 orders, how we can add to constraint to Nakul. So in place of Nakul, if we click and double click here, right hand side, in this place particularly, if we click on this place, we will have the options like add constraint. Now here in the constraint region, you must put on time off, and after that, you must give the date or deadline as 13th November to 14th November. So from 13th November to 14th November, Nakul will be off or he is in leave. Okay. So this is the constraint that we have added over here. Now after getting or adding the constraint, if we get to know about the schedule, again click on the schedule, you will check that the Nakul will be off here. Okay. That is Himesh and Srinivas is present, but Nakul is off here. Fine. Next, we have again changed the constraint and we make available Nakul here. And we have changed the speed as 5. So I don't know, 5 was initially there, but after that again, by deleting 5, we have to press the 5, and that was the secret that was told by Professor Peter. And we don't know that original reason behind it. And if we scroll it down there, we have to remove the constraint from that place again. Okay. So I have taken only one screenshot. I hope you understand and you can recall it. And if we add or if we make Nakul available, then again if we go to or click on the task schedule, then you can get to know that Nakul is again visible. So initially you can ask me that we had only 3 people available, that is Himesh, Nakul and Srinivas. And how we can get to know about Faisal, Wahid and Jishan? If we in the schedule part, if we are having one checkbox, if you uncheck that thing, you will get to know about all the resources over here. So that was the findings from that last day's morning session. Thank you. Absolutely.
Brilliant. Okay, so then now we come back to the lecture and we'll talk a bit about ontologies. So in general, you already understand maybe this, but some details maybe very some. Thank you very much. Give me a chance to switch on my computer. Yeah, and of course, what I would like to say that you see very clear, very simple, very understandable presentation, which is which shows that everything is very clear. Yeah, and so please do in the same way. Yeah, maybe add some conclusions, maybe give some comments. So. You are welcome, yeah, but just present your result, yeah. 1 second, we'll connect. Yes. Can you see my screen? So, and please, probably today afternoon, in about 4 o'clock, we will have some time to finalize the presentation. And please send me and all of us your results today, if possible. Okay?
Collaborative of one.
Yes. Okay? Will be possible. So we will give you time from 4 to 5 to finalize it, okay? And what is our plan in general on laboratory work? So in general, we already got the results from the laboratory number 1. Yeah? Tomorrow we will introduce, probably tomorrow, maybe today, but probably tomorrow we will introduce how to do other laboratory works just to support you. Yeah? And then it is up to you how many of them you can do it, because some of them require some computation. So you need to run system under different sets of parameters and then put it in a integrated diagram to show some interdependencies. Yeah. So depend what is the meaning of this laboratory work. So you change some parameters. For example, cost of courier. Yeah, and you see result immediately because now, for example, this courier is much expensive. Yeah, and he will not get some orders, and some orders will not get possibility to be delivered, or some other parameters which also can be changed, like speed of courier. So if they go with a in a more fast way, then they can do more orders during a day, right? So then the laboratory work can help you to just to make measure how much it will be, how much money they can make if they move faster, and so on and so on. So this is already some technical things, some research which very clear and understandable. So we think that the first laboratory work was most complex, difficult, and gives you some first understanding. So it will be up to you what other experiments to try. So, and coming back, let's continue our lecture. And now I would like to talk a little bit about ontologies and knowledge base. In general, you already practice this, yeah, giving some loading some ontologies, navigating through ontologies, editing some concepts or instances and so on. But now it is time just to have the overview of these things and to double check our knowledge and understanding. And again, some details you can find in the textbook. So, first of all, of course, I would like to say that this is, from our point of view, one of the key points of Industry 5.0. Because now we talk not about digitalization of data, but we talk about digitalization of knowledge. And this is big difference because we want to make next step in our computer systems. We want systems which support decision making. So the systems analyze options, try to optimize something, trying to find best possible match, and work continuously in real time and adaptive, of course. Yeah. And for these things, they need to know a bit more than traditional systems. And for example, competences of people, yeah, or technological processes, and some others. Usually, there are some information about all these things sitting in different enterprise systems. For example, in aviation plant, where we assemble aircraft, we have about 10 different systems which are required for our schedule. For example, one of them describes the structure of assembling product. Yeah? So the product consists of some parts, aggregates, and so on and so on. Another system consists information about technological processes. But when you take this information, you suddenly discover that there are not enough useful information. For example, they are not identifying in these technological processes competencies of workers, yeah? Or how time of operation depends from competencies and number of workers, because some of operations, for example, require not one, but they can be accelerated by when you bring two people together, yeah? Or three people. So, but this all information, it is only sitting in the head of managers there of the workshops, and when they leave for vacation or go to pension, yeah, this all knowledge goes to them, yeah, outside of the world. And so, but all this information is it gives us rules how to make matching, how to find reasonable resources for our operations, yeah, and so on and so on. So a lot of information which sits now in books and not available for analysis and formalization in some kind of rules could be given, could be formalized, could be separated from these sources of information and organized in a way, in a form of ontology. Of course, now when chat GPT is coming to everyone house, everyone enterprise, and so on, it's a very interesting question. How can it help us to build ontologies? So you can give some books of the enterprise, some documents, instruction, reports, and so on, and ask ChatGPT to build the ontology, which then we can use. So many interesting combinations could be now. But in any case, there are two options: or system learns by itself, or system learns by being taught by users, yeah, by experts, by knowledge engineer. And this is this concept of formalization of knowledge started with semantic web not far ago, but now already many companies, technological startups and researchers, they work around ontology, because ontology become one of most popular concepts to capture knowledge and formalize this knowledge. The only thing which we plan in future to consider is that we don't like that ontology is quite static. Yeah, so you collect knowledge, you formalize this knowledge, but next day this knowledge also can change. Maybe not so quickly like events which we considering resource unavailable and so on, but knowledge also dynamical structure. It also evolves and it also is changing, and also there are different views on the same concepts. It's a lot of interesting questions, issues when you use ontology. But in any case, it is a very, very big step forward in our information technology. And of course, when we first start thinking about how to find way to customize multi-agent systems with the ontologies, we of course start thinking what should ontology of enterprises contain, yeah, for planning. So we need to build some basic ontology. We call it in different names. It could be planning ontology, basic ontology for managing resources and so on. But and also to apply it for different areas of manufacturing, logistics, supply chains, and so on. Of course, sooner or later it will be a collection of different ontologies. And potentially ontologies could be considered as a separate product, which such people who have competences of knowledge engineers will create. Yeah? So it is a new type of profession on the market to become a knowledge engineer, not a data engineer, not a data scientist, but a knowledge engineer, and knowledge scientist, and knowledge officer. From our point of view, it is one of the key role in the enterprises 5.0, right? How otherwise how the system will operate without this knowledge, right? What in general, organization usually produce some products or provide some services. Yeah, there are also some team which works in some department. Yeah, team follows some kind of technological business process. Technological business processes consist from tasks or operations. Operations require different equipment or different workers or different drivers. Yeah. So in some sense, you start doing some kind of what we already use it, ontological models of enterprises. Yeah. And of course, enterprises, people from enterprises, yeah, they can build their own ontologies. I mean, already domain ontologies. Yeah, for example, if you manufacture aircraft, you will have one domain ontology. If you manufacture, I don't know what, cars, it will be another one. If you manufacture some kind of devices, it's the third part, and so on. The same with logistics of couriers, logistics of trucks, logistics of taxi, of supply chain, and of course they will require some collection of ontologies, and probably ontology will cost something. So it will be the product which can be sold, or you can buy ontologies one day. Yeah, but now we are making first steps in the developing these all things and trying to find compromise, to find some balance, not to make it too complex and abstract and difficult for understanding from one side, but from the other side to find a way to give possibility to customize for different enterprises. Yeah, and this is of course state of the art at the moment, but already we can see some very important things. So one of such very important things that you need to have more detailed view, more detailed specification for each task, for each operation. Because what planners do, they schedule tasks to resources, right, to implement some orders. And that is why specification of each task is so important. Yeah, it's how to say, this is the key, core part of all ontology. And in general, for future, what we consider, so we consider that every task will require its own specification, but also we need to specify what kind of input object must be available to start this operation. For example, if you are assembling some part of the aircraft, some parts of fuselage and wings and so on need to be before you make final assembly, right? If some of them delayed, if some of them not ready and so on, or not in the storage, how can you plan assembly, right? So these input objects, they play a role of some flags, which show you that everything is available and you can make this operation. But if not, then operation will delayed by agent of this. So these all specifications gives agents some instructions, yeah, what they need to check in their checklist, and if something is not ready, then shift it or do something, yeah. So basic agents, they have zero knowledge about the domain. Are we manufacturing aircrafts or some other cars or something else? But reading this specification from domain ontology, they get access to this knowledge. And of course, they not fully understand what we produce, what does it mean, car or aircraft and so on. But they know only that. But look, there are some conditions which need to be checked before we can implement this operation, right? And it's already enough for them. And all these conditions come from ontology. Yeah, is it clear? But gentlemen, ladies, are you clear what I'm saying? Yeah, right. So this is we call this diagram between us semantical spider of each task. Yeah, because it's we don't know any one scheduling system which drills to such level of the details. And when you give people such possibility to describe in such way, each task in their organization, of course, it requires some effort, but then for people it is much more understandable what system is doing, yeah, because it tries to find input objects, or what is also very important. I think this in our demand supply networks, probably this is the main discovery. The main discovery is that the main relations is in schedule is required. So you can see the relation number 4 here is that you can specify for each task, you can specify requirement. And we have even some cases when you can add some requirement on the fly. And you put it in ontology, and then adaptive scheduler will react on the event that knowledge has changed. So now I need to schedule my resources under slightly different rules, and schedule will change. Yeah, and this is, from my point of view, this is also the second moment of truth. Yeah, because now this smart system or intelligent system for resource management, it is really knowledge driven, knowledge based. And this opportunity gives chance to people on the ground, in the workshops, who knows how to drive trucks and so on, to bring some small but very tasty details, which sometimes are so without details you can build any reasonable schedule which is close to reality. Yeah, it will be always some abstract, and people will hate it, because if you produce not a reasonable schedule, they look on this schedule and no, we are looking in a different way, and they will immediately forget about it. They will do not in the system scale, but they will do in usual way. Yeah? So they will take telephones, they will call, they will organize meetings, and they will waste hours to coordinate their plans. This is also stupid. Yeah? They will waste time, so much time. Yeah? I think that maybe tomorrow we need to make one exercise to understand how can we measure benefits and efficiency which we bring to the clients. Yeah? And let's maybe do it in a step, because if you can come to the enterprise and ask them how many hours or minutes you are using every day for dispatching, for some meetings in your control or operational center, yeah? When you give tasks and then you control how they implement and so on and so on. And probably they will say, oh, we have every day 1 hour meeting. Yeah? How many people participate? 10 people. Imagine 10 people multiply 1 hour, it's already 10 hours in a day, you just burn, yeah, waste of time, yeah. Why not to have in your mobile all this and to see where is the problem, yeah, and then participate in such meetings only once and in that moment when system cannot not able to solve the problem, yeah, because doesn't know how to bring 3 additional workers tomorrow, yeah. But people know. They can call, invite, pay some extra money, or ask them to work in the evening. Yeah. So to overcome limitations which are sitting in the system, yes, this is a human role. But to do some regular, routine work of management already not needed. Yeah. And if we multiply these all savings, then we immediately 1, 2, 3 steps, and we come to the how much money in a year we can save to this company. This is something which starting point for negotiation price for our shareholders. Yeah. So requirements could be not only to employees' competencies, but also for equipment, or some other instruments, or some other things. Yeah. But then, of course, you need relation number 1. It's a previous and then the next task. What is the reason? Why do you think this relation is important? Can you give me some ideas? Yeah? We talked about this relation. Now we're talking about previous and number 6, next. So relation between previous task and next task. To fill new task.
New task in between. To shift the.
Yeah, you're absolutely right. But let's start from the simple case. Yeah, simple case is that if my operation or input objects not ready,
Then new task
Yeah.
cannot be.
we cannot be able to plan in some. Then we need to inform next who is in our technological process. Look, we are not able to do this. Yeah, wait. I will tell you later. Yeah, or something like this. Yeah. So, looking on this structure, you can, in all detail, you can develop some interesting strategies for agents. For example, with whom communicate. Yeah, because if you know who is the next task, you already know whom you need to inform, or your operation has delay. Yeah, whom you need to inform when it of course next one. Yeah, so each of them is very important because they directly influence agents what to do. Yeah, clear? And of course, then you need to generate some output project, and then also you can develop agents. And for example, give, I forget probably to put the number here. So if you put this ontological specification of your task here, you can think what other relations could be used. For example, if we see that system allocates young engineer to some task, maybe it will be reasonable to give him information who are very professional, very experienced people who already implement many of such tasks. So if I'm a young engineer, suddenly not only task will come to me and will knock my computer, are you interested to take this task? But also it can give me some additional advice that look, if you are worried that you have not enough competences or experience, you can call this person, yeah, or talk with him. Yeah, he was absolutely brilliant in executing these operations in the past. Yeah, and so this person can make a call and ask some small details, and so we also help in such a way. We also can help people to become more productive, not only efficient. Yeah? So, and some other. So, some of them, of course, you can add without any reprogramming, but some will require reprogramming of agents, because if you want to have a full spectrum of such kind of relations, you need to make some pre-programming of this. But then, what I want to mention, pre-programming and reprogramming means that you are not doing it for specific enterprise. You are developing something very generic because it will be used also for many other enterprises, because you're trying to generalize the structure of your agent, basic agent, yeah, class of agent. Yeah. So it will be reusable. So after all, we have such vision of structure of ontologies. Yeah, don't be afraid of such complex diagram. I will try to explain, and in general, this is a very simple thing. So you have here basic ontology. Basic ontology, it is an ontology which doesn't have specifics of any enterprise. It is something about task, resource, process, product, and person, and so on. Yeah. So it is not about aircrafts. It is not about couriers. It is not about any other domain. Yeah. It's like this yellow part in there. I don't know English word how to call it. When you have eggs, yeah, yellow part is the core part of this product. Yes, but then based on this basic ontology, you extend this ontology for different domains. For example, aircrafts or cars, product, or gas, oil, and other. Yeah. So you have basic ontology, and then on this, sorry, here, and then using these ontologies, which could be, I don't know, 150 concepts relational, you come to the enterprise, and then in the enterprise with this domain ontology, you will generate. You need to add some instances of these classes, of all these entities, objects, concepts, relations, and so on. Then you form a ontological model of this enterprise. When you already describing names of workers, drivers, numbers of their cars, and so on and so on. And finally, on the next level, you have what we call scene of enterprise. Scene of enterprise, it is a model of enterprise, but for particular concrete moment of time. For example, 12 o'clock, yeah, who is where, who is doing what, yeah? 6 couriers, one here, one there, their positions. So when you have this, it's like a photograph, it's like a snapshot, yeah? which describe your enterprise at any moment of time. So we think that it is very typical for many applications to have basic ontology, and you have this independent from domain. Yeah? Then you have domain ontology, but domain ontology is not new ontology, it is extension of the basic ontology. And then using this extension, you build ontological model of enterprise. And then you put it into your system, and system generates things, yeah, because it starts scheduling and understanding who is doing what and when. Yeah. So in general, this picture is clear. Yes. Mm-hmm. Yeah. Good. So, but just small video, but you already you know all these things. Sorry for Russian languages, but it's not important here. So this is basic ontology, which we made for one of the enterprises. Then we extended to domain ontology, so it is much bigger, yeah. But then we take, it is for assembly aircraft. Let's take one workshop. It is about 100 people, yeah. So you can see ontology of one workshop, yeah, which is already, yeah, it's because it describes, but look, what it describes every one worker, his competencies, in what business processes they take part, where this part in the whole, and this is only one workshop. And what I can say, but don't be afraid, to build such ontology, you don't need months. It's about 3 days, 4 days, 5 days, yeah, you just you need to collect this info from different sources, integrate, formalize, and integrate. Yeah. So, but coming back to our cases, yeah. So,
So, example of scenes of enterprises. Is it? Can you show us the scenes of enterprises in that semantic way?
yeah. Still, in this knowledge base which we bring you, because we spend some time to translate it and so on, it's a version where you scene is not presented. So scene is sitting in UMass.
Okay.
IRMS.
And but it is in new versions. We need to look a little bit to bring it here. Yeah. In the new version of UMass, you already can see scene like this, like galaxy. The big galaxy of stars. Yeah. You can see there. So, but it's already in a new version. We need to look a little bit to bring it to this one. So, as a result, what we have basic ontology, yeah? And basic ontology also interconnected with UMass basic agents. So our basic agents, they understand basic ontology. And then you extend it in domain, and then these basic agents generate instances when you load it of themselves. And each agent gets pointer to ontology. Where is his ontological description? He finds this, read this, and now he not generic agent. He becomes agent of specific order, resource, technological process, task. So it is now not generic agent of task, which knows nothing about your domain area. But now it is agent of assembly, I don't know, wings to the aircraft fuselage. So he knows who is in, what input objects I need, what kind of workers I need, who is the next, who working after me, yeah, in our technological, and so on and so on. So now he somehow customized, automatically customized for this particular domain and enterprise. Clear? Okay. And then domain ontology. Domain ontology extends the basic ontology, for example, for logistics. And we're working with logistics ontology and with already more specific classes of concepts and relations. For example, employee, vehicle, process, operation, tariff, and some other. And based on domain ontology, an ontological model of the enterprise to be created, which contains specific instances of objects and relations. And here is we can see an ontological model for company which we use, and also on the right side you are opening employees card, yeah, or employees instance.
Here we have basic ontology, logistic ontology, and logistic company model. Okay. Suppose this is for the logistics company. Now, if you have another company, suppose the basic ontology will be same. Just we need to make ontology for that company and company model. We just need to add 2 more JSON files for different companies. The basic ontology will be same for all the other types of companies.
Basic will be same for all types of companies. If we come, for example, for courier companies, yeah, probably domain ontology will be absolutely the same in New Delhi, in Moscow, in New York, but models, ontological
models depend on the company's demand.
Yes, will be absolutely different, yeah, because you have 100 couriers, I have 3 couriers, you have trucks, yeah, and so on and so on. So, but if we switch from couriers to truck management to truck companies, they potentially will have some other specifics in the domain. For example, some trucks could have specific equipment to put heavy loads, yeah? So you need to specify this.
In the basic ontology. In the basic
Not in the basic. It's in domain, yeah. And this equipment will be added to each truck which has this, yeah. And then when you bring new order, this order will go to find technological process, and then will go to the operations and will find that, look, for such very heavy load, I need specific equipment. And I only can find trucks and use who have this equipment. Yes? Understand? You got it. Very good. In a few minutes, you got everything. We spent 10 years on you got in a 5 minutes. Very good. Okay. And of course, you can navigate through, and Valery already showed you many times how to do this, and you already made all this on your own. But just to check our understanding. Yeah? So you can navigate through, and of course you can also navigate from company to employees, from employees to competencies, from orders to resources, products, technological process, and all other entities which you have. And also to simplify a little bit design or redesign of ontologies, we use this Excel file, which just yeah, excuse me for 1 second, may I finish paper? So what we found, for what reason we use Excel file? We found out that when you come to the enterprise, sometimes it is where people don't want on first stage to learn about these all concepts, relations, and so on. It's much easier to give them something simple, Excel file, say, look, start simple, yeah, and explain to them how to put this addition. Usually, if you give them example, they already understand very quickly in 5 minutes what to do. Then they can fill these forms, we can check them, and then we one click and we upload them to the system, yeah. But I want to just to highlight that, look, you have here link, because Excel is additional information, yeah? So it needs some link to what ontological model it will be loaded, need to be loaded. And the second, for each concept, we need to specify class and ontology to whom these instances, yeah, will be linked, yeah. Then what is very important? So, but of course you understand. So if you change domain ontology, so structure of this Excel diagrams will change, need to be changed. Yeah.
If we change the main ontology, then we have to change the structure of this Excel. Yes, understood.
Yeah, because if you add more, ontology will not be just recognized what you're talking about. I have no idea about. Yeah. So that is why Valerie made some work to just to help you using these tools to prepare this Excel file. You just few clicks, you change it, and you just to simplify and save your time. But if you extend domain ontology, it could be that Excel file structure needs to be changed. Yeah? But it is more or less stable. Or if you go from one courier company to another, it probably will change. So then of course you can drill into concrete persons, concrete tasks with some specific equipment on board, and so on and so on. Yeah? For example, like this in this example, we talk about the competence to deliver oversized cargo, big cargoes, yeah, and you can do it with a big car or truck. With, for example, here it is a capacity of 2 tons. Yes? And of course, the corresponding classes you can find in your Excel file. And what is interesting, you already fully familiar with all these things. It is just to check that we all understand in the same way. Yeah? So here it is in Excel in such way we represent relations between the same, just using very simple tables. We are saying that item number 3 related to item number 5, and to see who is number 1 and who is number 5, you have a special table for which describe this concept. Yeah? So the same story with freight cars and types cargos and trucks and some other. So I suggest we make some short break, yeah, 5-10 minutes. Then we'll continue. And I want, after yesterday's discussion, I slightly changed my slides. I want to tell you a little bit more and some different applications, just to trigger your imagination and some sorts where could such system could be developed for such kind of project.
So using the platform that we have already discussed, can you give some application such that they can group wise, they can develop within a short period of time, 2-3 hours or in a day.
But look, what we are doing here in this laboratory, look, we are developing such kind of application for the courier. But
This laboratory development starts 6-7 8 months and Excel sheet with particular requirements in सबसे update करना है और वो update करने के लिए जो पूरा courier model है उसमें changes आने हो सकते हैं कुछ नया type of couriers add हो जाए नया types of tasks add हो जाए
so we use it, this platform, yeah.
No, yes, sir, remember it's the
पूरा अलग ही
modification,
but
full
full day
model
model
is modification.
No, what I am telling that, for example, they have their own platform. Using that platform, can we develop a new application for the specific requirement of us?
You mean, so what I want to explain. So in this platform, we work in a simulation mode. So we put couriers, for example, couriers for affected resources, workers, for example. You send orders and we make schedule. And then you can say, worker not available, on hold, new order is coming, and you make change, adapt. If you talk with application for end users, yeah, not for developers, but for end user, yeah, real couriers who will go in New Delhi.
Let us take an example in Durgapur itself, or in many other cities of India. There are a lot of food delivery companies. Food delivery companies.
It's like a courier.
Yeah.
Are you okay? So,
Food delivery companies.
yeah.
Okay. So there are many persons who work for this food delivery company as a delivery boy.
बच्चे रखिए क्या हो रहा है तुम लोग को
So there are a lot of food delivery boys who deliver food. So what you can do, you as a person, you can book food, you can order food. You may order to some app or a particular restaurant.
Yeah.
Now the third person who is working as a delivery boy, he will pick up the food from the restaurant
Yeah.
and will deliver to your home or to your office.
So there is a third party involved in this communication. Unlike other delivery where the company has a delivery boy of himself, here we have a third party of delivery boy between a company, between the producer and the consumer, sir.
I got your idea. So,
May I draw the diagram?
yes, you need to know.
And the thing is, what I am looking for, can you guide these people to develop such application?
Yeah, absolutely.
Maybe within 2 days or 3 days, they will work in the night. It is not an issue. Maybe they may not have to work in the office itself. Even after the lab, after the class, they will work in the night and all. But at the end, they will complete the whole application, like from scratch.
Yeah. I think there are two options. Or here is it, yeah. Or you write it on your own using, and we will give you API that you can use ontology APIs, yes, and scheduler. But you make the application and on your own, or we even can bring to you some pieces of such kind of area. You can use it, yeah. So we just will decide.
So there are different restaurants.
Yeah.
There are n number of restaurants. There are n number of restaurants who are producing food.
This is a customer who order food.
So, for example, we want to order food, pizza, or the
Now,
team.
there are different delivery boys who pick the order from one restaurant and provide it to the customer. Now, this customer can be of M number of customer.
Yeah.
So there are M number of customers, there are N number of restaurants, and of course there can be any number of delivery boy. Now, there are some delivery companies as well.
Yes.
For example, Swiggy, one delivery company. Zomato is another delivery company.
Fantastic.
Uber may be another delivery company. Now, these delivery boy may be working for one company.
Yeah.
Sometimes they are working for 2 or more companies together.
Shared resource.
They have their bike.
Yes. Yes.
So you as a customer, you are ordering a particular type of food from a particular restaurant using any of their app.
I don't want to care about what company. I want my pizza in 1 hour.
Yes. But I know from where I am booking.
Yes.
Whether I am booking it from City Residency or any other Pizza Hut or maybe
But
Domino's.
for
That is my
example,
choice.
Yeah, I, for example, not caring from what restaurant. For example, yeah, because I need to do it, to have it for 20 people. In,
Yeah, so customer may have a different requirement. The customer can have a time constraint requirement that I need it immediately, maybe within 10
Yeah.
minutes you can deliver it.
Then we have a
I am very hungry.
criteria as fast as possible.
Yes, I am very hungry, I need
As
immediate
soon as
food.
possible.
This can be one condition. There can be another requirement. The customer is looking for a particular type of food from a particular type of restaurant.
Or as cheap as possible.
Or easy is possible. So this type
Company
of
should be just different. In that case, company should be the different because from any company, Swiggy, Zomato, or Uber, they can order the item.
yeah, rating can be one of the another criteria. Rating,
Rating, of course, quality of
quality of food.
of course, absolutely.
So I'm looking for pizza which has the highest quality.
Yeah, but it could be also quality of delivery, right? Because you can have a very good restaurant, but guy who will bring you will fall down.
So my idea is using the platform that you have, can we develop some application for this purpose?
We must. Yeah, I think yes. And we have very close developments for trucks. And what I can do, we can, because this we are discussing during this course, not the whole application, yeah, because it needs mobile devices, some user interfaces, reports, and so on. We are not caring in this course about this. Money transfer and so on, we are not touching this all very, how to say, routine part of the application. We're only talking about intelligence,
Yes.
collective intelligence, yeah. But the huge part, big part of the ready-to-go solution is, give me just a pencil. So, for example, we have here web system for administrator of such system, yeah, one part. We have web system for clients, yeah, because these clients need to do. We have a web portal for dispatchers, yeah, dispatchers who potentially could work governmental or company, yeah, because all work 90% is now done by systems, not by dispatchers, yeah, and how we call it delivery boys, yeah, web system for delivery boy, yeah. And these all systems somehow interconnected. There are some security, there are some other important features, but we can give you this as a basis, and using this you can adapt it for couriers. Or you can, if you can write down it, but it also some work. Yeah, it's maybe not one day. Yeah.
So the thing that you have formed, that is the basic ontology.
No, what I'm saying is not about ontology. Yeah, what I put it, but in the middle of this, yeah, we have here our intelligent stuff, ontology plus UMAS.
Okay.
Yeah. But this is web applications which are, how to say it, support technological process. If you order a pizza, this order should be stored somewhere. It goes to UMAS. UMAS process it, generates schedule goes to selected delivery boy, yeah, and then delivery boy, we need to control delivery boy. So delivery boy need to click button that I accept order, yeah, because maybe he's sleeping somewhere. Then he need to click button that I got pizza in the restaurant. Then he click button that I start moving because it's digital twin, yeah. We have a digital twin of this all voice, yeah, delivery voice. And then when he coming to the customer, also same. I'm at place of the customer. The customer need to confirm that he get the pizza. So, for example, this one is a step-by-step business process which need to be supported. Yeah, in some sense we have already in place. Yeah, but you need to adjust it for this particular application, because maybe they, I don't know, to check something, some codes, security and so on.
So far what I have understood that in UMAS file, that in UMAS the Excel file contains actually all the relationship that was actually provided, that was actually built based on the ontology, right? That means all the relationship which will be the subset of whom and would be the primary key, secondary key, and all the relationships are actually present in that particular Excel file. And based on that, the ontology actually acts, right? So based on our applications, it will change.
No, not in UI. First of all, these all concepts and relations which describe this model of business, yeah, sitting in the ontology, in domain ontology, basic and then extended domain ontology, yeah. On this basis, we create ontological model for this particular platform as Animesh proposed. We will not have ontological models of these companies because we will be independent third-party platform which compete with these all existing companies.
Yes.
But these companies also, I think, we need to think and can cooperate because for them, for example, we don't know how they make this scheduling right now. Maybe they will outsource to this platform, to our platform, their functionality, so they can. So if I say, this is our platform, yeah? Our platform. Here in the middle, yeah? Not only delivery boys can, and not only customers can work here, but also maybe some of these companies can register as a company, add their ontological model for their own goals. So we will not work like this to delivery boys, yeah. But they will have a nest somehow in our platform. And they schedule their couriers in their for their own needs. So we don't know who is their customers. They come here, and delivery boys go there with our schedules. Yeah, so we can cover both business models, right?
Your platform will remain same and we can put as per our own created ontology. Based on that, it will be
It will work based on
that's why it is
domain
open source.
ontology. No, Open source, it is a different story. Open source, when we give you source code of the platform, so you can do whatever you want. Rebuilding agents, editing new agents, any type of modification, yeah? So there are some options on that, because when you make changes, then the question who will be responsible for the result. If you make some bugs, then you already losing control, yeah, of all this thing. So, but I think that the idea is absolutely brilliant. And probably there is a niche of the market, and we can try some hypotheses. We can talk with these guys. We can go on our own, and you can use our existing concepts, or you can make it from scratch. And
So basically, what we are proposing is what sir said. So you just modified it like one customer will not choose the like from the restaurant, particular restaurant, but there will be like a distributed network of restaurants, and I'll just order the food, and that the network will decide depending on some parameters which restaurant to choose, and then
It depends on the requirement of the customer.
yeah.
For example, the customer is very hungry and he wants food, he doesn't bother where from the food is coming.
And the restaurant having less load will be
Simple load balancing.
Okay.
But if you want specific restaurant,
That I am looking for pizza only from Pizza Hut.
Yeah. I mean there is a flexibility.
So whatever time it takes, I don't bother, but I will take the pizza only from Pizza Hut.
but what I add to Animesh's idea, he said, let's build a platform
Yeah.
to compete with existing small or big companies who delivering food. Yeah. So our platform, you specify what kind of food you want, we deliver. Yeah. What I'm trying to say that also in parallel we can work with this, because we can give them our schedulers and say, look, 1 rupee per head of the courier in a day, and you use our scheduler. Yeah? They will decide how much we can together we can make together some evaluation. Yeah, will it be profitable for them or not? Because if they have 5 dispatchers or 3 dispatchers, yeah, we can reduce number of dispatchers to 1, for example. Yeah, it's immediately some costs. Yeah, and all other benefits. So it is, but it is another business model, and I think it is also possible. Yeah?
Yes,
So that we are not working with clients and delivery boys directly, but we give them chance to build their own virtual artificial intelligence company in our platform, and they are working with customers, they are working with boys. It's just alternative way. I think both ideas are very interesting, and so we already have 2 hypotheses to check.
So we can work in parallel.
We can try these hypotheses in parallel.
So both can work.
Yeah, and we can see that in Animesh case, how much profit we can do in a year, yeah? And in this second case, how much we can do in a year. Yeah? We decide what is better for us. Yeah. Yeah.
So actually we have Swiggy, Zomato, Uber, and this kind of so many applications currently available in recent market, like Basket, Swiggy, Mart, multiple Instamart. So multiple shopping applications are already available with us, and that particular applications are currently on your AI. That is what the search say to you. Based on the recommendations, they will recommend you. Suppose you are searching for one particular book. And next they will recommend you that whether any particular, the same story what happened in case of Amazon and Flipkart, they used to suggest you what you want. All those things we have already. Then if we want to incorporate these things to your platform, okay, then what advantage we will get? That is, they are also working on scheduling. They are also working on privacy.
Main point. You miss that. We are not competing with services which make recommendations. Look, we spent 3 days talking about scheduling, only about scheduling. Why you are talking about merchant with best possible recommendation? It's not in our topic, yeah? We make schedule, we help companies to deliver much efficiently, 10%, 15%, and so on. We are not giving recommendations. And what we are talking about, that we can with Instamart or Amazon or Alibaba.
So let me clarify her question more detail here. Her question is, this is now just a moment, you can order food from Zomato or Swiggy, right? So obviously they are following some sibling algorithm. It may be adaptive, it may be non-adaptive, they may be using ontology, they may not be using ontology, but they must use some intuitive idea to deliver my food.
Absolutely.
Maybe that scheduling algorithm can be of manual, that can be a paper-based scheduling, whatever.
It can be, and I can tell you that probably 9 to 1. They use some algorithm.
They must use some algorithm.
First income, first in, first out. Yeah, just
It can be any algorithm,
Yeah.
and they must be using that.
Yeah.
Otherwise, they cannot deliver.
yeah.
Her question is, tomorrow let us produce the app, the scheduling algorithm, then design the application, everything. And what will be our proposal to sell this product to this company, and what will be our UCP? USP.
Unique sales proposition. Yeah.
I mean, why those people will purchase our product?
There are.
Right?
Right. This is
For
the
the
question.
question that I
Yeah, sorry, then I missed your question. So, we already have two hypotheses.
Because the moment we will go to sell our product to this company, they will say, we have already scheduling algorithm. Why should we purchase it? Why should we pay ₹1 or $1 per order?
Yeah, because we said, look, will be better quality and better efficiency of your resources. Up to
How do you?
10, 15%, 40%, and so on. How you prove?
Yes.
Yes.
Very simple. We will take some case and we'll see how they schedule their resources under the same conditions. To run, for example, in parallel, what we do for Lego, how it happened. Yeah? They give us some case and we run in parallel how we scheduling and how they scheduling in SIP. Yeah? And then the result was 18% more profitability. Yeah? And then how they take decision. Yeah? So, or you can use historical data, but historical data is not very good for such experiments about the real-time scale because you don't know who was there. So you know when order came and how it was delivered, but you sometimes in this system they're not keeping information, full information about the context. What was, who was where and there, and what they doing, you're doing, and so on. So, but under these circumstances, we say that we will be better with the schedule because of adaptability, which we already discussed in the time. So, but you're absolutely right that they can say, how much they will save us, maybe 10%. What is the reason for us to change our schedule?
Yes, yes. That
And this is potentially absurd, but then we have what Animir said, that we can have a platform which will just have chance to customers and restaurants to and delivery boys to meet each other, yeah, and to work together, yeah, and there will be a competition.
So, sir, I have just one query. So, for this time, we are developing one platform where I, as a company owner, can register our company, and our platform will only do the scheduling of the algorithm, scheduling of the order.
Yeah.
Nothing more than that.
Yes, yes, nothing more.
So after scheduling, so suppose I am a company owner of Zomato, so I register in this platform.
Yes.
So I add various constant that this order, then I get the scheduling from this platform.
Yeah.
So after scheduling, I as a company owner, I have to again do some kind of constant of the customer. Again do this what Sir said, that I have the various constant. I as a customer have a constant to take the order from Pizza Hut, to take the order within 15 minutes. So this kind of constant I have to again check in our company side. So I will only get the scheduling of the order from this platform.
There are also some options. You could thank you for good question, because you can or make scheduling in our platform, or vice versa. You can ask us and we will give some software to you,
Okay.
and you will use APIs, our APIs. So you have the same interface of you are this company, yeah? You already invest millions, yeah, to build some applications and so on. For what reason you will change something and will go to some third-party platform, yeah? No, you will stay with your own application. But then we can say, option number 2, you can just give us, we will provide you APIs, we will install our system on your server. All users' interfaces will be the same for your clients and so on, but inside you will have better schedule. This is second option. Also possible, but we don't know right now this market. Yeah, we need to spend 1, 2, 3 days just to understand how they work. Come to this 1 or 2 or 3 companies. Yeah, talk with them, interview for 1 hour. Yeah, saying that we are doing some research and we are thinking about new artificial intelligence for the courier companies. Yeah, can you give us 10 minutes to or 1 hour for interview? Yeah, we can learn about some business process, compare 1, 2, 3 companies, generalize this idea, and come up with some first prototype. Yeah, and then check it in the bottom and decide what way to go. Just calculating how much money we can gain from this case. Yeah.
So, whatever our real status is that we are familiar with Amazon, Flipkart, and other applications. So, where I found that priority basis work has been already done there. So, we got some of the order based on our priority. So, maybe some schedulers are already there. That's why they are doing.
No, of course, there will be similar.
We discussed that we are, look, we start this course saying that we have some ideas how to make scheduling better using artificial intelligence, but not machine learning, because machine learning, for machine learning, you need to analyze data in the past, and every time something changes. Yeah? So this data will be out of date sometime, one day. Yeah, but we're using a little completely different technique, and this technique gives you very important feature, adaptability, because you are not just putting place orders in open source. You solve conflict, and it helps with less resources make more orders. If it is interesting for them, we can have a deal. If not, no problem. Very simple.
So if we want to make
See,
a
what
prototype,
Amazon and Flipkart are doing, basically they are checking the person's previous purchasing also, and by that they are tracking that, yes, it is needed for her or maybe him. So they are getting this thing by fetching all this previously data.
Whenever you are fetching something, then your AI is already incorporated.
Yeah, definitely.
That is for recommendation.
That is already, but the
Recommendation
scheduling
and
thing
this
you are
is
saying,
entirely
no?
different.
Yeah.
It's
Yeah,
entirely
that is,
different.
that is like
Better
Scheduling.
Yeah, it is about better
better
scheduling.
scheduling.
It is about scheduling
We
in
can use
real
this for
time.
better scheduling
Better
and better.
scheduling
So,
and
scheduling
you
in
can,
real time.
increase the profit by
One-
using the scheduling.
question.
as well,
One by one.
IKMS, sir, we are having a prototype of the logistic company. Now we are working on a prototype. If we want to make a prototype of this model in IKMS in the existing IKNS, then what is the step? How can we as a group,
Exactly, that is
we
my,
as
that
a,
is-
we as a part of this conference, sir, can be divided into different groups, make a we don't need a real business model at this point. Just as we are working on a prototype on example data sets, how can we make a prototype of this model which sir has proposed, where there are three parties involved: customer, restaurants, and delivery partners, with some constraints in each department. How can we make a prototype sir, that as a different groups of students to make a small business model? So what are the steps, sir? How can we do that?
Very good question. Let's think together. How can we
Yes,
do
sir.
it? And
from where to start and how we should proceed.
yes, yeah, because I think this is a brilliant idea. And
Because maybe Saturday you will be leaving from here, everything will be closed.
yes, I
That I
said,
don't want.
yeah. What is my
At
so,
least some of the ideas should come out from this discussion.
absolutely and my,
Some of the business model, some entrepreneurs.
yeah. So my proposal is that I will reduce lectures a bit, but I want very much to show you we have in plan this network of schedulers. Yeah, and it is what we started discussing yesterday. You said you have some case in mind. Yeah, I want and I asked my boys, and they are preparing now some small prototype to show. It was not in our plan of the course, but we want to demonstrate it and to talk with you. So I will revise my slides, make it shorter, but give chance to show the. And then probably tomorrow, yeah, we need to complete this discussion and spend some time in the workshop, yeah, developing steps how we can do this, yeah, converting the idea into the action plan, right?
Sure.
And it will be very important outcome of all these discussions.
Yes.
Because one story is to discuss endless theoretical issues, yeah, but just have a chance to make a good business. Why not to try? Yeah. It's a education in society 5.0,
Yes, sir.
based on industry
Industry
5.0.
Yes, sir.
5.0. Good. I think very good. I think it is a bright idea. Yeah. So, what shall we do next? Or just let's continue this discussion. So we plan to have a break. So
Yeah, that we can do.
let's have a small break and then we'll continue.
You can be.
Oh, no, thank you. I have one. So, yeah, instead of talking of applications from the past, I think you should talk about applications for future. Yeah? It's much more interesting. Yeah, right? So, yeah, break. 5 minutes. So the option one, restore numbers. 1, 2, and line. 1, 2, L. Yes. So this is, let me say, option number one. That there is a platform where clients, restaurants, and delivery boys can register, and then system helps them to organize the delivery. Looking on very different criteria, but also doing some interesting stuff, like maybe consolidation, maybe dynamical pricing, maybe some other interesting feature which other companies not able to provide. Yeah? And that is why this platform could be in general, could be in future, become more popular. Yeah? This is number one story. And here we have a direct competition with already existing delivery services. Right? Option number two. Yeah, and our client is the client who wants food delivery. Yeah? Option number two is that what is the name of this company? Swiggy. Yeah? So, case for, let me say, case, let's call first AI platform for food delivery. Yeah? Is number one, option number one. Option number two, client is Swiggy or any other service like this. Yeah? So Swiggy has their own databases with some software. Yeah? For scheduling and some other services, yeah, right? For example, payments, security, all this stuff. And they work with clients, client one, client two, client three. And so what we do, they have some part here, some service, some subsystem, yeah, and we give them, and we install on their server our knowledge base, which is prepared for their ontological model, and plus you must. And this is, it works here on their server in an integrated way. Yeah? And it all sits under their security, under their control, under, how to say, all things their responsibility. Yeah? So clients, they have the same user interfaces, they have the same counts, everything is the same. Yeah? But what we do, we give them instance of our system, which is customized for them. And we are not providing user interfaces and so on. So we make only, if we can take additional money only for integration. So we integrate with their, let me say, their platform. So all this stuff is there. If they want to give some interesting new, fresh, tasty features for their customers, they slightly adjust their screens, make some changes, small changes and so on. But it will be still their own system and our subsystem, and not a big problem. Yeah? And this is option number 2 we discussed, yeah, right? Are we on the same page, yeah? Or this number 3, number 3 option is that we provide platform for companies like this. So now this part will everything the same, but this part will stay in our platform. So this is a platform for delivery providers, so how to say, delivery companies. Yeah? So this is already now our platform. It's like this, but much simpler because we don't need to work with the end users. We have here for each company like this. What is the next?
Zomato.
Zomato. So it's our platform. These companies, they have their own software, but this software will work with knowledge base and UMass for 3D. This one, knowledge base and UMass for.
So for each company, we
For
have
each
to separately make the
separate instance inside our platform.
And will this collectively be a single system for the customers and restaurants, or what?
We are not working with restaurants, and
But
they ask us to schedule. We like a black box for them.
Okay.
So the same for all other. So we look like a technology provider, like a service, for example, electronic maps, yeah. So they can use so many instances. How many companies are on the market, yeah? And we check it. So what I want to visualize this discussion which we have before break, yeah? I think that it is not there, yeah? There could be some other options, possibilities, yeah? How can we bring it to the market, yeah? Okay? Would like to add something? Want to add something? Yeah, so how to convert it into the because what I want to say, what is the difference between these options? In this case, when you become provider of food for customer, for many, maybe million customers, yeah, for Delhi, for Calcutta, for other old cities, yeah, then you need to work with clients, so you need to process payments, you need to provide security, you need to provide good interfaces for users, different type of mobile devices. So you have such a big head pain to work on these all things, yeah, and it will require some time and efforts, yeah. In this case, you only provide some piece to them, yeah. So this work is much more. So this is the simplest one. Simple. You can start it. This one is simplest one. You can start it tomorrow on Monday. Just prepare some ontological models for them, customize them, provide them this installation on their server, integrated, and done in 3 days. So this is probably this one. Let me give my expert opinion. Yeah? Time. I think it is not less than 3-6 months. Cost high because you need to have a team. 35 people, 5 programs, or some others. Yeah. Full-time employees. Yeah. Time, cost, team.
Best options is
So this one, option number 2. So this one, time from my point of view, 3-6 months, cost high, because team will be required 3-5 full-time employees. Here time is from 3 days to 3 weeks. Oh, maybe you correct me if I'm wrong. And this one is time probably 2-3 months. Cost little, but because you need here to provide computer powerful servers, yeah, to run not one but many, and to keep them safe. Because if something happened, electricity is over, or something like yesterday, I was in the hotel, suddenly light switched off, suddenly, yeah. And so you will need some money to get a very good server. Yeah, so or you need to rent it somewhere in cloud and so on. And team, 3-4 people per team. Yeah. So this is something just to start thinking. Yeah, for some first estimations. Maybe I'm wrong. Yeah, in some estimate, but this is some intuitive. So this is most interesting and most advanced, but also expensive. Yeah? This is some very, how to say, safe, yeah? Because you use one company, something happens, you can quickly fix problems and not a big deal. And this is in the middle of something, yeah? It's probably better to start with this and then go here and then to go there. But you find that this is already okay. So then I suggest we stop and go for lunch. And after lunch, if I understand correctly, Animesh will tell us. He will run lecture for you 1 or 2 hours, something like this. And then what I'm proposing you, take 1 hour from 4 to 5 and complete your reports on laboratory work. And it will be fine. Yeah, we will complete this part of, okay? And tomorrow plan will be for tomorrow. Tomorrow, yes, I forgot to say that. If you have time, we can continue this discussion after 5 o'clock. If not, then on Friday morning, I will make a lecture about this network of channelers. And Valery is now preparing some case, some small prototype program to give you one example of this. And then after lunch, we can also continue developing some action plan. Clear? Agree? Yes.
So the second option that you get.
Yeah.
So for that, this system that already is there, that knowledge base plus humans, that is already there. So we have to first like have to choose a specific customer. For example, say then we have to
Access, yeah.
and then we have to design the ontology corresponding to that,
For them, yes.
and then
Not only ontology, domain ontology, maybe extend. You don't know how to use thermostat or not, or cold or big size cargoes or parcels. We don't know. We need to learn this. And then adjust domain ontology and then adjust ontological model. This is number one. The second one, job, is to integrate. Yeah. So we give them APIs or they give us, and so we somehow make organized transfer of data, yeah, and events. And that's all.
So obviously they need our APIs.
Sorry,
They obviously need our APIs.
we can provide this. We have all APIs, no problem. Yeah. Questions? Maybe you have.
Yeah, actually I have. So as I'm working on swarm robotics, okay. So being a swarm robotic algorithm developer, what are the exposure in this particular your field? Because as I'm relating, most of the work is based on the agent-based system and networking and distributed ways. So being a swarm robotics developer, algorithm developer basically. So what are the exposure in your particular field? So how can I enrich my knowledge, use my knowledge in this domain?
You just, instead of couriers, put your robot. And your robots will be scheduled to do some work. For example, yeah, let's describe your robots. I don't know what kind of robots.
Swarm robots is basically less powerful robots, and we create a more powerful algorithm so that that algorithm can work instead of powerful robots. We can use less powerful robot to work the same, to do the same work. You know.
Yeah, but that give me.
In terms of if we use memoryless and miniature robots instead of a large powerful robot, okay. So the thing we will achieve the same thing, but less cost will be very less, and if we are creating
I
so many
like
robots.
this idea. I like this idea very much.
Yeah.
Instead of one big robot, one big satellite, one big airplane, and so to have many small. Yeah, I fully, I'll say it, I understand it. But I want to know a little bit what kind of task you want to solve. Yeah, what is it? Is it
Actually, some examples like search and rescue. Okay, so there is search and rescue a person. Okay, so imagine a scenario where some person is got stuck in an endangered area. Okay, and nobody is there to help that person. Now, if and that entrance was somehow closed inside, and nobody is trying to enter in that particular area. Now, a big powerful robot, a single robot is not able to get into that particular endangered area. Now, instead of that powerful robot, if we are creating some miniature robots, okay, they do not have such potential, but as they are working in a swarm, they get into that area and try to rescue that person from that endangered area.
I like this idea very much.
Yeah,
I will show you one.
So I actually want to know what are the applications based on swarm robotics, so I can relate my work with that particular domain.
I suggest we sit down and talk a little bit about this because I have some proposal.
Yeah,
I just will show you one example which my guys sent to me in the morning. Just one second. Just 1 second. So, this is what does it mean? So you have a swarm of UAV.
UAV, yeah.
Yeah. So unmanned flying flying vehicle, aviation aviation,
Yeah.
so flying vehicles. And then, for example, because of some people lost somewhere, you have some region, and you need to make inspection, so you have, for example, 5 drones, and you want to send them to cover this
Region.
region, but you have drones which are slightly different with speed, with batteries, and so on, power. So somebody need to sit down and to understand what will be the rule for each.
We will create some rules that how they are working, operating.
So in this particular case, which my guys developing right now, they decompose the whole region into some pieces,
Okay.
and these pieces become demand. They are crying, come to me, please investigate. Maybe these people are here who is lost, and different drones, because they know their capacities and so on, they try to fight and compete for each small space here,
To access that space.
to access this,
Okay.
and suddenly the whole route, all routes for them emerge from this competition and cooperation. The same story like in scheduling, but now they
Scheduling in terms of ranking, who will take that chance to access that particular area?
and here's also how so in green line it is one drone, in a red lines it is another one. So suddenly you see that it is a very strange picture, not unusual, because usually they go in one direction and they very, how to say, stupid, in this sense, but here they compete. Who will go there? Looking on their cost, time, because their flight was different.
So the while they cooperate with each other, like conflict and cooperate, after that the end result is the schedule. The movements of them are scheduled in a.
Yes, of course. So if I'm better for so each circle
Yes, sir,
here,
yes, sir.
it's like agent,
Yes, sir.
which demands, come, please take photo of me, take picture. And different drones compete saying, I will be better for it, I will be better for it. And this one decide who is better for him at this particular, looking on what kind of equipment he has, like couriers, because good camera or bad camera and so on and so on, and then finally they build the route. But it is not only competition, it is also cooperation, because if I take this part of the region, you will take some other, because I'm better here, because I close to this area, and you are better in something else, So such kind.
Less chance of collision for that
Yeah,
particular.
and of course, no. So we are not doing on-board system, to avoid collisions. But when you make planning, you do it for, of course, for the reason not to have any collision and not to duplicate imaging, and not. So you want to, as always in our applications, you want to make more orders with less resources, right? To burn less money, to waste less time, and so on. This is just one example. You can find hundreds like this. Let's cooperate on this. This is not absolutely not a problem.
Thank you, sir.
Thank you for your question and this fantastic. Yes.
On that slide.
Come back to the slide. Or, sorry,
So basically, what I'm
oh, it's probably different. It's not WhatsApp, it is. Here it is. This one.
yes. So basically, there are some regions that are overlap. That is the part where conflicts happen.
You mean overlap where?
Yes, suppose this blue rectangle and that is the red rectangle and some
Yeah,
regions.
but this is not the collision, it is how they go there. So it is in different time intervals will go. So for this picture, very important for us that finally equilibrium is like this, yeah. So how they divide region into pieces, yeah. And no, it is not about the schedule.
At
Yeah.
some interval, probably that blue one is like covering those points or the points, and at some other interval, the red one.
Yes, yes.
They're not working parallelly. You mean to say, once the green one is covering, then the yellow is happening, then the blue is happening. Sequentially, it is happening, not parallelly.
No. They can work in parallel. Yeah, but no collision because
See, they
We
are
are showing-
creating some scheduling algorithm, so
Yeah.
there is no chance of collision. Like they do ranking, who will access that particular area. So I think there is, the scheduling is there to
Avoid
make
collision.
them, about the collision. I think, sir, am I right?
slightly different.
Okay,
So in this task, we are focused not on scheduling.
Okay. Photo
We are
snapshot.
focused on
Snapshot.
how to distribute tasks, sub-regions between drones, looking on when sub-regions would like to be imaged, what kind of equipment we have on drones, and what is their speed, and what distance they can do.
Sir, if they are with same speed and same computational capability, in that case, it will do the same operation? See, I'm trying to say that they are homogeneous in nature. All
Yeah,
the
if
robots
they
are
will,
same.
look, if they will be in one time, in one place, in the beginning, for example, sitting here, somehow they will divide it in similar pieces, probably, yeah. But if they are in a different place in the beginning, and have different speed and different capacity and so on, the picture will be different. And what we want to show is, this is not the final product yet, but some experiments, yeah, how you divide. And the picture looks unusual.
No, so you are considering the same capability robots in this case? Homogeneous robots, or robots may have different capabilities, like in terms of speed, computational capability,
Different, of
size,
course, of
everything are there.
Different, of course.
Different, okay.
Yeah.
So it could be some different thing if we are considering robots are homogeneous, means they are in terms similar in all respects.
Yeah, of course. And using this simulator, you can try different colonies of robots, comparing,
So you make groups and
yes,
okay.
and comparing who is better in these cases, who is best in these cases, and so on. And also showing that one big usually can do some work maybe better, but in general, when you have unpredictable circumstances and so on, usually a swarm is better. Yeah.
Obviously. Yeah.
So you can prove it not by talking, but using some tool, yeah, for simulation.
For simulation.
And this is very interesting because I'm absolutely sure that Industry 5.0 will be for swarm of such unmanned vehicles in the space, in air, on the ground,
On the ground,
underground,
as well.
in water, underwater, everywhere. Yeah, and then also some of them will also coordinate each other. Yeah, satellites will tell drones will tell land vehicles and so on. Yeah, and you need to build a multi-level network of such things. Yeah, why not to take it as your research? We will help you.
Yeah,
Absolutely.
sir, I would like to.
I will be happy. We will be happy to.
Okay, we'll mainly in this regard, definitely.
I think that smart robotics, swarm robotics, is a huge area, and we already working with a swarm of satellites. We already working with swarm unmanned vehicles, and some other. This one is some steps in the drones. So why not to make some interesting research together?
Emulate all this.
Okay.
So I have one question.
Oh, yeah, very good.
So
Yeah.
what she was saying,
Step by step. Yeah.
what she was saying, just continue with that. So if robots are homogeneous, so obviously the distribution will be unique always.
Usually what?
I mean, if robots are homogeneous,
Yeah.
so obviously the distribution will be unique always.
Will be what?
Unique. I mean that suppose
What do you mean unique?
I mean the position. I mean, okay, it could be like the robot, the starting position of the robots could be different.
Everything could be different.
Okay.
Everything.
For a certain point of view, I suppose that
All this technology, multi-agent technology, works very well when you have not a situation that all your resources are absolutely the same.
Okay.
But when we have some individuality, yeah, some their preferences, their specific constraints, their different criteria,
And all
then it is best possible match. Then you really need multi-agent system. If you have absolutely same resources and nothing changed, you don't need all this stuff. You stay with SIP, Oracle, and all this stuff. Yeah, you don't need new technology. You don't need intelligence because there are no any intelligence, no need for that. Yeah. Please.
As we have told you that we are working on swarm robotics, and we are working on in discrete domain, mainly focused on explorations of any graph or any continuous domain.
Or explorations of what?
Explorations in discrete domain, any grade
Sir, discrete
or
domain in the sense ki, we are working on
graphs,
rates
grades.
like that only. So instead of 2D environment, we are working on graph, and robots will explore the graph adjacent nodes, and they traverse all the nodes, and they say that all the nodes will be covered by at least one robot. No node should be uncovered. So this is how their exploration to the grids or graph or like that.
Oh,
Just
okay,
this is
okay.
denoted as discrete domain.
So you
And
This
have,
is just like a graph grid
this is
structure.
just to check my list. So you have a graph. For example, this graph could represent rooms on this floor. Yeah.
No,
Yes,
sir.
no, no,
you
So
need
this,
to explore.
so this structure is like a grid structure. This is also a graph. This is also a graph. This is the grid
Yeah.
of n by n.
Yeah.
So we have to explore all the nodes
Yes.
in the grid.
And in different time, and also some nodes could demand to be explored in different time, because what is the reason to send drone with vision system when it is night, not in the night time? Yeah.
Yes, yes. This is not our question. Sir, I want to know, sir, in this case, the collective intelligence, how the collective intelligence can be used in this exploration cases.
Oh, very, very strongly, because if one robot has found something, he need to report to other that, look, guys, don't go this place and stop your activity because we found what we want. Yeah, you already found. Stop. Come home. Go home. Yeah, back home. Or so they can share. They must share some information between them. to help each other. And this is the main concept of designing distributed system. You need to explain to yourself, first of all, and then for your customers, how it will help you to solve the problem. And in our case, absolutely the same story. So our agents make local search.
In that case, memory should be
Give
required.
me a chance to finish. They make local search, but they somehow report the results to other because they have preference and so on. So they, by definition, this information helps them to take decisions collectively, right? Yeah, please continue.
In that case, memory is required.
What?
Memory. For
Memory.
yes.
No, I don't know what memory you have. And is it a problem to have some memory? Right now you have a gigabyte.
Actually,
robot.
sir, to store the intelligence concept, to store the knowledge.
Look, to store the knowledge, you
Yes.
don't need gigabytes. To store the knowledge like an ontology, you
Okay.
need very small, it's nothing to discuss. Yeah? Compared to the huge data which comes from different sources, knowledge is a very small storage. Yeah?
Okay.
But of course, if your robot makes imaging and you would like to build 3D landscape of the environment, you of course need some knowledge. But it is not my question. It is, you need to decide how much memory you need on this. We make only clever stuff. So how they generate decisions, how they coordinate decisions, how they make planning, replanning, and so on and so on. But to process images, it's not our domain. By the way, we have some ideas how to make multi-agent system for image processing, which will work completely different according with it, because it's the same story. So pixels need to fight for some patterns, and patterns need to fight for some pixels. And it could be some unstable equilibrium, how to distribute pixels to the patterns. Yeah, we had such experiments with clustering. Maybe I later, if you will time tomorrow, I definitely very eager to show you some interesting results where we apply the same technology, sometimes the same basic ontology, but completely different applications. Text understanding, clustering, design of territories in Moscow. Just surprisingly wide with the same basic ontology. Yeah? Can you imagine? Yeah. But what does it mean? Maybe it is my personal main discovery in the last 20 years that such kind of algorithms and methodology can help us to solve so different, so complex problems in a very short period of time. And this is maybe the main lesson which I would like to share with you, just to attract your attention. That, look, of course, you are very advanced people who have a lot of knowledge and intelligence, but look, there are also some interesting methodology here which can help you to use, to be applied for solving very complex tasks. And it will help you for your research and academic career, or maybe for business or some development and so on. Just have a look.